In this video, we will learn about some important terms regarding electrolysis. Electrolytes. These are either acids, bases, or salts which in molten state or in aqueous solution allow the electric current to pass through them and get decomposed due to the passage of electric current. Electrolytes are either electrovalent compounds. Electrovalent means ionic compounds such as NaCl, copper sulfate, NaOH, etc. or covalent compounds which form ions when dissolved in water such as hydrogen chloride, which is HCl. Whenever it will be dissolved in water, it will decompose into its ion, that is H plus and Cl minus. Non-electrolytes. These are the compounds which neither in solution nor in molten state allow the electric current to pass through them, and they are called as non-electrolytes. Example, we have alcohol, sugar, carbon tetrachloride, which is CCl4, then glucose, benzene, etc. Now, electrolysis. So it's the process by which an electrolyte gets decomposed when direct electric current is passed through its melted or aqueous solution placed between two electrons. So simply we have a solution or an electrolyte which is in molten state. We'll simply pass the electricity, but the condition is that we must properly set up two electrodes and place the solution between them. Electrolytic cell. It's a non-conducting vessel, generally of glass, in which electrolysis is carried out by passing electric current through two electrodes placed apart in the solution, or the melt of an electrolyte is called as electrolytic solution. So here we have, this is the electrolytic cell, simply made up of glass. Inside this we have electrolyte, which is basically either in molten state or the aqueous solution. Here we have two electrodes, anode and cathode, which basically are connected with the battery. Anode is connected with the positive terminal, whereas cathode is connected with the negative terminal. So this battery is not the part of the electrolytic cell, as we are able to see that. So electrolytic cell converts electrical energy into chemical energy. Electrodes. So electrodes, in order to carry out electrolysis of an electrolyte, aqueous solution or melted solution, two plates or strips or rods of metallic conductor or graphite are always required, which are connected to the two terminals of a battery, as just we saw in the last diagram. So these are known as electrodes. The electric current enters and leaves the electrolyte through electrode. So basically they act as a passage for the electric current from battery to the solution. So the anode is the electrode which is connected to the positive terminal of the battery. The current enters the electrolytic solution or melt through electrode. Cathode. This is basically connected to the negative terminal of the battery, and the current leaves the electrolytic solution or melted solution through the cathode. Now the difference between cathode and anode are given in the table. So simply, anode connected to the positive terminal, cathode negative terminal. Anions move towards anode under the influence of external EMF or external electromotive force, which is simply due to the battery, and get discharged on the anode, whereas cation moves towards cathode under the influence of external EMF and get discharged on cathode. Then we will see that oxidations of anions takes place and cathode reduction of cations takes place on cathode. Ions. Now what are ions? They are simply atom or group of atom which carries either positive charge or negative charge. They are simply called as ion. So the ion which carries specifically positive charge called as cation, example Na plus, sodium plus, copper plus, ammonium plus, etc. So the ion which carries negative charge, it is said to be anion, example chloride, hydroxide, phosphate, etc. The charge on an ion, whether it is positive or negative, it is simply represent the valency of that ion. Now the differences between anion and cation. So first of all, anion negatively charged, cation positively charged. Anion migrate towards the anode during electrolysis and get discharged over there, whereas cations migrate towards cathode and get discharged over there. So anions basically give up electron, as they have excess electron because they are negatively charged. So they have more electron, then they will give their electron to the anode and get oxidized to become a neutral atom, whereas cations take up the electrons from the cathode and they will get reduced to become a neutral atom or molecule. Now what is oxidation? So it is simply increase in the proportion of oxygen or an electronegative atom. For example, magnesium on reacting with oxygen will give us magnesium oxide. Here we are able to see that on the reactant side magnesium is alone, but on the product side we have oxygen along with the magnesium. So we will say that magnesium has been oxidized. Similarly, FeCl2 on reacting with chlorine will give us FeCl3. Now the electronegative atom, basically which is chlorine, has increased, so we will say that FeCl2 is oxidized. Also, oxidation is the decrease in the proportion of hydrogen. For example, oxidation of H2S into sulfur. So here we are able to see that this is H2S which has hydrogen. On reacting with chlorine, we will get HCl along with the sulfur. On the reactant side, H2S has hydrogen, but on the product side, sulfur do not have any hydrogen. So we will say that H2S is being oxidized into sulfur. But according to electronic concept, loss of electron by any atom or ion or a molecule is called as its oxidation. Means if sodium will lose one electron to become Na positive, we will say that it is oxidized. If chlorine lose one electron to become Cl2 or Cl atom, we will say that chlorine is oxidized. Similarly, Fe2 plus, if it will lose one electron to become Fe3 plus, we will say that Fe2 plus has been oxidized. Now, oxidizing agent. So these are simply any species, atom or ion molecule which oxidizes other substance. Agents work for others. So that's why oxidizing agent oxidizing the other substance, but they will itself get reduced in the process. So they are called as oxidizing agent or oxidant. Common oxidizing agents are oxygen, ozone, chlorine, bromine, manganese dioxide, potassium permanganate, potassium dichromate, nitric acid, etc. Reduction. So it is simply increasing the proportion of hydrogen. Cl2 on reacting with H2S will give us HCl plus sulfur. Now we will see that chlorine was alone in the reactant side, but in the product side it has one hydrogen atom. So we will say that addition of hydrogen or increase in the proportion of hydrogen in chlorine is the reduction of chlorine. Then second is it is decreasing the proportion of oxygen or any electronegative atom. For example, CuO plus H2 will give us copper plus H2. On the reactant side, we have copper oxide, means copper with the oxygen, but in the product side, we have only copper. So we will say that copper oxide has been reduced into copper because it doesn't have now oxygen. Same for ZNO plus carbon, that will give us zinc plus carbon monoxide, and here SnCl2 is being SnCl4 is being converted into SnCl2. Here we will see that here in the reactant side we have 4 chlorine, but in the product side only 2 chlorine atoms are there. So this is basically decrease in the proportion of electronegative element, which is chlorine. Then according to electronic concept, gain of electrons by any atom or ion or molecule is called as reduction. For example, if copper 2 plus will gain 2 electron to become copper, we will say that copper 2 positive has been reduced. Similarly, Sn4 positive on getting 2 electron will be converted into Sn2 positive. We will say that this Sn has been reduced. Similarly, sulfur on gaining 2 electron will become S2 negative, means sulfide ion. We will say that sulfur has been reduced. Now, what are reducing agents? Simply agents which works for other. So these are species, ion or molecule which reduces others and itself get oxidized in the process. So they are reducing agent or reductant. Common reducing agents are hydrogen, carbon, which is basically coke, charcoal, carbon monoxide, sulfur dioxide, stannous chloride, sodium, aluminium, etc. I hope it is clear to you. Thank you.